Hold a tiny specimen up to the light. Naked, I can't see what's hiding in plain sight. But stack two lenses in a metal tube, and suddenly you've got a massive magnified view. First lens catches light bouncing from below, creates an upside down image in the glow. That picture becomes a target for lens number two, which blows it up again for me and you. 2,000 times bigger than reality. That's the magic of compound optics, you see. Multiply the powers, 10 times 40's your game. 400 times magnification's the name. From cells to crystals, everything gets revealed. The microscopic universe unsealed. Remember those two lenses, working as a team. Objective down below, creating that first scene. Then eyepiece up top, acting like a magnifying glass. But here's the catch, the closer you get, the faster light will pass. Crank it to 100 times and you'll need oil between the lens and slide to capture every photon beam. More power means more light to keep the image bright, cause higher magnification steals your working height. 2,000 times bigger than reality. That's the magic of compound optics, you see. Multiply the powers, 10 times 40's your game. 400 times magnification's the name. From cells to crystals, everything gets revealed. The microscopic universe unsealed. But wait, there's a limit, physics won't let you break. Light waves diffract through that circular aperture shape, creating error discs with rings around the globe. 2 points blur together when they get too close below. 0.61 times the wavelength divided by NA. 200 nanometers, that's as good as visible light can play. No matter how many lenses you stack up high, diffraction's fundamental, wall you can't deny. So why does oil immersion push past what air could do? It boosts numerical aperture, the light collecting glue. Remember, resolution equals wavelength over NA. Bigger NA means smaller distances you can portray. From Rayleigh's criterion to super resolution tricks, standard storm found ways to beat physics. Fluorescent molecules light up one by one, proving even diffraction limits can be out